So hello everyone, we are now on week number 9, and this is now going to be lecture number 17. Crazy how fast the semester is going. And we're going to start now. I'm going to share my screen, and we're going to start on chapter 11, which is measures of position. We got to 5 number summary. Oh, so we already started this one. Wonderful.
Yeah, a little bit.
Yeah, wonderful, wonderful, wonderful. So we did the 5 number summary. Thank you. So we've already done the 5 number summary? Okay, excellent. And we did the box plots?
Yeah.
Excellent, excellent. So we actually then...
Oh, I guess we finished. You're right.
I think we finished this then. Did we do this scene here?
Yeah, we sure did.
Sweet. So we are on 12, moving right along. That's great. So let's download number 12 on the mean. And let's do that one. Okay. So we have not done this one yet, correct? Okay. So we are on the mean right now. Another word for mean is average, but the word average is not as precise because there's different types of averages out there. The mean is just one of them. It's one specific type of average. And the mean is the easiest, not necessarily the easiest to calculate, but it's the easiest conceptually, because when you're growing up and you're in middle school or grammar school, even in elementary school, and you take a few tests and you want to know what your average is, what do? How do you compute the average?
Add them all up, divide.
Right, you add them all up and divide by how many tests you took, right? That's the mean. That's exactly what this big formula is on the board. To compute the mean, X bar, add up. So this symbol, this Greek capital letter sigma, means add up all the values in the data set and then divide by how many values there are. And that's the mean. That's the first formula. To compute the mean, X bar, add up all the values X in the data set and then divide by the number of values. So the median is one measure of center, and the mean is a different measure of center. And this whole chapter is about the mean. Okay? So let's do an example. To compare their weekly allowances, some children made this chart using an applet. Ari makes how much money per week? What's Ari's allowance every week?
$5.
$5. And what is Beth's allowance every week?
$10.
$10. And so on for Cheng, Doug, and Irvin. So the question is, what is the mean? What is the mean allowance? So what do?
Add them up.
Is it 5?
Well, we're not going to do it by looking. We're going to do it by calculating.
So 5 plus 10.
5 plus 10.
Plus 7 plus 6 plus 5.
$6.60.
How much?
$6.60.
I don't know. I didn't do the math. Let's take a look. So we're going to do 5 plus 10 plus 7 plus 6 plus 5. And then we divide by how many?
5.
5. This is X bar, by the way, X bar. So 5 and 10 is 20, is 10, and 20 and 27 and 33. 33 over 5 is 6.6, $6.60 on the average. Is this a histogram? Is this a histogram?
Crickets. I forgot.
Yes. Is this a histogram? Huh?
Because the bars have to touch, right?
Yes. First of all, the bars have to touch, which they're not. Second of all, for a histogram, this is not categorical. This is not each person. A histogram has, it has to be quantitative, has to be numerical. On the bottom, oh, that was really a catchy little jingle there. Everyone heard it, right? It wasn't just me making some weird
It was my
motions.
sister's phone.
Okay. So is this a histogram? The answer is no. And if not, they say make a histogram. Well, for a histogram, what we need is a horizontal scale. What should every tick mark represent on the horizontal scale?
The allowance?
But I need numbers. I need numbers.
5, 10, no.
Well, each tick mark is 5?
No, one singles, right?
I don't know. You tell me. I'm asking.
I guess you could do 2s.
Okay, so 2s. So 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, and let's throw in 10 to 12. So this is the allowance, and the vertical axis is always either a frequency or a relative frequency. So how many allowances fall between 0 and 2? How many
None.
allowances between 0 and
None.
2? Not everyone at
None.
once now. Huh?
None.
None. How about from 2 to 4?
None.
None. How about from 4 to 6?
2 of them.
2 of them.
5.
Right? 2 of them.
What about 6?
Because remember, if you fall on the border, our convention is that you go to the right, the next one,
Okay.
right? So 5s fall inside, but because 6 is on the border, 6 would go into the 6 to 8 category. How many go into the 6 to 8 category?
2.
So that would be Chang at 7 and Doug at 6. So that one is also 2. And then
Professor,
Yeah.
is there any way you can scroll down? Because I can't see the bottom. It says 2, 4, 6, 8, 10.
Yeah, nothing's below that. That's the very bottom. I'm not writing anything below that. So 8 to 10, anything in that one?
No.
And how about 10 to 12?
1.
1.
1. So this would
Professor,
be, yeah,
I'm sorry, what's the vertical thing over there?
frequency.
Oh,
How
frequency.
often? Frequency. How often? This will be a histogram. Okay, nothing wrong with the bar graph. It displays the same information. Actually displays better information because the bar graph tells me the exact values and the histogram lumps them together. All right, we don't know where between 4 and 6 if I just look at the histogram, but I do know exactly where it is from the bar graph. So in this case, the bar graph is probably a better idea. Okay, any questions on that?
Yes. Oh,
Okay,
never mind. Hold on. Next to the 10, is that a 12 on the bottom?
yeah, 2, 4, 6, 8, 10, 12. Okay,
Yes.
all right. So let's scroll down. So the mean and the total, okay? So don't forget, if the mean, which I'm going to rewrite the formula for, if the mean x bar is equal to the sum of the x's divided by n, then if I cross multiply, I get this formula, that the sum of the x's is also equal times the number of values times the mean. It's just a rearrangement of the same formula. Okay, sometimes you're going to use this formula depending on the situation, and sometimes you're going to use this formula depending on the situation. We're not going to do this exercise because we're not in class. So I'm just going to go ahead and move to the next slide. Okay. Microsoft Word will give you readability statistics for any text that you write. One statistic, the Flush-Kincaid grade level formula, gives the grade level of the text. It is computed using this formula. 0.39 times ASL plus 11.8 times ASW minus 15.59. That gives you your grade level. What does ASL stand for? Well, it tells you it's the average sentence length. In other words, the number of words divided by the number of sentences. If you make very small sentences, that's a sign of a low grade level. If you make very long sentences, that's a sign of a higher grade level. The ASW is the number of syllables per word. In other words, the average number of syllables per word. So what do? The number of syllables divided by the number of words, right? Longer words have more syllables, another sign of a greater grade level. So according to this formula that Microsoft Word uses, it tells you your grade level. So here is a text. In interviews with fourth graders, many students consistently associated the typical or usual or average value with the mode. In constructing data sets that have a given average, they made all or most of the values the same as the average value. A paragraph like that, would you think it's a relatively high grade level or a relatively low grade level? Just intuitively, without doing any calculations. What grade level do you think would be appropriate for a paragraph like that? Would you say a third grader can write that?
Third or fourth, maybe.
You know of a fourth grader that will say something like, in constructing data sets that have a given average, they made
Oh, no. Never mind.
the same as the average value. I don't know any fourth grader.
Never mind.
Oh, definitely like high school.
Definitely high school or higher, right? That is not a elementary school or middle school type paragraph, correct? So let's actually compute it. Let's start with the average sentence length, which is the number of words divided by the number of sentences. So let's calculate how many sentences there are. I'm going to call it S. How many sentences are there in this paragraph?
2.
2. How many words are in this paragraph?
2.
2 words? In interviews, that's already 2 words right there. There's a little more than that.
$41, I believe.
42.
42.
How did you guys get 42?
How many words? You just count the words, right?
Not the words. 42.
42.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13,
I also
14,
got
15,
42.
16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36,
Okay,
37,
I
38,
understand.
39, 40, 41, 42. 42 words. Now, how many syllables? We'll call it SY for syllables. How many syllables are there? This is a little tougher. In, int, views, with, fourth, graders, many students, consistently, associated, the typical or usual or average value with the mode in constructing data sets that have a given average. They made all or most of the values the same as the average value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 50. 1, 2, 3, 4, 5, 6, 7, 8, 9, 60. 1, 2, 3, 4, 5, 6, 7, 8, 9, 70. I count 71. And I label them, and I would recommend if you actually came across a problem like this somewhere to do it like that, because otherwise it's very easy to get lost.
Did anybody else get 72? Anyways, whatever. Yeah.
I don't know. It's about the same. It's going to be off by a decimal. So 0.39
right.
times. Okay, so now what's the ASL? What's the ASL?
Average sentence length is 2.
No, that's how many sentences. That's not the average sentence length.
Oh.
They tell you the number of words divided by the number of sentences. So what's ASL?
Number of words divided by
42 divided by 2.
So 21. And hold on, Chipotle. Angela, how long ago was that sentence made? I just saw it.
A while ago. It's okay. I haven't gotten any answers yet.
Okay, because I'm hungry now and I want some Chipotle.
I'm still
Chipotle
waiting.
sounds so good.
Feel free to type in the chat.
I'm gonna eat Yoshinoya in like 30 minutes, so
Our class is not over in 30 minutes.
it's okay. I'll still eat it here. It's not a problem.
Fine. Okay. So what's ASW? The number of syllables divided by the number of words. So how do I do that?
It's 1.69, so 1.7.
Yeah, 1.69 is good. I'm going to use the whole decimal. So 0.39 times the ASL times 21 plus 11.8 times the ASW minus 15.59. This gives me a 12.04 grade level. So according to Microsoft Word, this was written by a 12th grader, which seems relatively appropriate, correct?
I have a question.
Yes.
For next, when you give us another problem, is the ASL and the ASW gonna tell us what to divide like this, or it's just gonna be constantly the same thing?
Well, these are the definitions of ASL and ASW. So if you ever come across them, these are their definitions. They don't change.
No, like I'm saying, if you give us another word problem that doesn't involve sentences, you see how it's in the brackets, is that gonna be there?
You mean this part here?
Yeah.
Well, not anymore. Now that we know what an ASL is, you should understand the definition.
Okay.
Okay.
So the 1204 is because you subtracted, right?
Now, the 1204 is I put everything into this formula here. I actually,
with the
I actually,
15 put in?
yeah, I actually calculated the grade level.
Okay.
Okay. Okay. Now, when it comes to the mean, there are what are called models of the mean. And what that means is there are visual displays that, or visual understanding of the mean that can help us really internalize what the mean is. Okay. And it says here, the mean is a grade 6 California Common Core state standard. The mean measures center in the sense that it is the value that each data point would take on if the total of the data values were redistributed equally, and also in the sense that it is a balance point. So we're going to do it both ways. Okay. We're going to understand the mean both ways. Of course, we have the mathematical formula, add them all up and divide by how many you have. Nothing wrong with that. But we're going to approach it in a different way where we see two different ways of visualizing the mean. So example, a class of third graders sat at different sized tables. They noticed that the 4 students at the green table had a lot of brothers and sisters. To help the students quantify this observation, the teacher asked each student in the class to take 1 cube for each brother or sister they had. The students at each table put all of their cubes in a pile and then redistributed them so that each student had the same number of cubes. At table green, and how many students were at table green, by the way?
4.
4.
4. Each student had 5 cubes with 2 cubes left over. So how many, so first of all, how many cubes were there at that table?
20.
22.
22. 4 students, each one had 5 with 2 cubes left over. That means there's a total of 22 cubes, right? So first, which part of this process represents adding all the values? Which part of the process represented adding all of the values? Remember what we did here. We put all the cubes in the table, and then we redistributed them so that each student had the same number of cubes. So which part of this process represents that portion of redistributing? Adding all the values. That's put all their cubes in a pile. Right? If each one has a specific number, think of it like my test, your test, his test, her test. How do you get the mean? You add them all up, and then you're going to divide by how many you have, correct? So the putting them all in the pile, that's the adding them all up part. Hi, Liam. Okay. Which part represents dividing by the number n?
Putting them on each table? Or like,
Well, no, we're only looking at a table. Every table is different.
The redistribution between the 5 students.
Yes, that's the redistribution between the students, the 4 students.
So it'll be 11 divided by 5.
Where do you get 11 from?
You said add all the values.
Add all the data, there's 22 cubes in total,
Oh yeah, sorry. So 22 cubes.
right? And we divide them amongst the 4 students, right? So that's
Yes.
dividing by the 4, that's redistributing them so that each person gets the same amount of cubes. Now that part's not really important. What's important is what's coming up. And I don't even care about this. Okay. If the siblings of the students at table green were redistributed equally among the 4 students, each would have how many siblings with how many siblings left over? Okay, the same situation that we just did. Each would have how many siblings with how many left over?
Would it still be each would have 5 siblings?
Each would have 5 siblings because each one has 5 cubes. With how many left over?
2.
With 2 left over. Okay. So now let's do an example which is a little more clear what I'm talking about. The 4 children at table green were asked to take 1 penny for each brother or sister that they had. They arranged them as on the following page. So we have the 4 students, Justin, Sophia, Carlos, and Alia. How many siblings did Justin have?
5.
5. And how many did Carlos have?
5.
I don't think Carlos had 5.
Sophia or Carlos?
Carlos. Oh, no, sorry. I meant Sophia in my head. I'm sorry, but Carlos. Okay. I
8.
apologize. So Sophia had 8 and Carlos had 5 and Alia had
4.
4.
Okay. So the students said, take 1 penny for each brother and sister and arrange them as in the following page. The teacher asked them to level out the towers of pennies so that they were of the same height, removing any extra pennies. So in other words, took this one and moved it there. and then removed the extra pennies. Agreed? That's what we have going on here, correct?
Yeah.
Okay. So how would the tower look after children finish? Well, I just showed it to you, right? It's got an even height of 5 with 2 left over. Notice how this is exactly the same thing with the blocks, right? With the cubes, right? Each one had 5 with 2 left over. Okay. So the mean as okay, so that's one interpretation. One interpretation of the mean is by redistributing so that everyone has the same amount. You redistribute it, you take some from here and put them here so that everyone is equal. And then you have a little left over at the end. That's going to be your decimal. But that's one interpretation of the mean as a balance, as a redistribution of wealth. Okay. Also called the Robin Hood method. Why do you think it's the Robin Hood method? What do you think that name?
Rich.
Huh?
You're taking away because
Taking from the rich and giving to the poor.
Right. You're taking from the rich and giving to the poor, right? You're taking from the ones who have a lot and giving to the ones who don't so that everyone's equal. Okay. So the other method is the balance point method. And the idea of the balance point method is as follows. If I were to put a block, if I had a board, like a wooden board, and I put a block at each value, and some blocks here, some blocks here, some blocks, same size block, but different, different spots, then depending on where I put my finger, the board will either balance one way or the other way, correct? It might tip one way or the other way. Wherever I could put my finger so that it's perfectly in balance, that location is the mean. So if I look at this picture up here, I see lots of blocks on the left, they pile up on the left, and I see lots of blocks on the right, but they're more spread out, just lower. But because of distances from the center, the balance point is right here. Okay, and we're going to demonstrate this in the following example. The dot plot below gives a number of brothers and sisters reported by 12 second graders. If you count how many dots are there, there should be 12 dots, correct? How many of those 12 students had no siblings?
3.
No. How many had
Student number
0 siblings?
5.
1. Student number 3, so 1.
No. These 5 dots. Those 5 dots are the 5 students who had no siblings. 4 students had 1 sibling. 2 students had 2 siblings, and 1 student had 4 siblings. The question is, what is the mean? So let's compute the mean. Let's not do it by any other method, but by computation. 0 plus 0 plus 0 plus 0 plus 0 plus 1 plus 1 plus 1 plus 1 plus 2 plus 2 plus 4, all divided by 12. Gives us how much? What's the mean of this example? Do that computation. Do the computation. Don't guess.
it's 2.
Do the computation. Don't guess.
Oh, I didn't.
Well, where are you getting 2 from?
So 4 plus 2 plus 2, which is 8, plus 5, 6, 7, 8, and divided by 4.
I'm confused. 4 plus what?
Plus 4, because 2 plus 2 is 4.
That's 8 plus how much?
Oh, sorry. 9, 10, 11, 12. That's
12
divided
plus
by 4.
Why divided by
wait.
4?
Isn't it just 1?
It's 1. We divide by 12, Miriam. We divide by 12. There's 12 people here. 12 dots.
Oh, okay. So you don't divide by the number over here. That's a 4. Okay, I see.
Okay, so this is the mean. Now my claim is this is the balance point. That's my claim. This is the balance point. Let's check. Obviously, any blocks that I put at the balance point are going to keep me in balance, right? They're not going to tip it one way or the other, right? right? If I just have blocks at the balance point and nothing else, it's gonna be balanced. This 2 here and this guy here are each 1 unit to the right, so they also balance. Agreed? If I go 1 to the right and 1 to the left and put a block on each, it's gonna stay in balance. This one here and this one here are again 1 unit left and 1 unit right. Again, balance. Correct? What about these 3 guys here that are a total of 1 to the left, 1 to the left, 1 to the left? How do I balance 3 guys that are 1 to the left? By having 1 guy that's 3 to the right. This 1 guy is 3 to the right, correct? And these 3 guys are 1 to the left. So I can think of moving 1 and moving 1, moving 1 and moving 1, moving 1 and moving 1. So a way to think about it again is move them 1 at a time. Move this one 1 to the left. So move this one 1 to the right to balance. Move it again 1 to the left. Move 1 to the right to balance. Now I have 3 that have to move 1 to the left. Well, I have 3 that can move 1 to the right. And when I do all those movings, I end up with everything right at the balance point. So the idea of the mean is that if you move things towards it, you end up with everything at that location and you are perfectly in balance. That's the idea of the mean at the balance point. So let's see if they have another one. 9 students were asked how many blocks they lived from school, and their answers were 1, 3, 4, 4, 4, 5, 7, 8, 9. What's the mean of those numbers? Go ahead and calculate it, please. What's the mean of those numbers? How do you calculate the mean? By doing what?
You add all of them together.
You add them all up and then do what?
Divide by the numbers, the
Yeah,
amount
how
of
many,
numbers you added
I
together.
got 5.
Excellent. Excellent.
Fine.
So 1 plus 3 is 4, 8, 12, 16, 21, 28, 36, 45. 1, 2, 3, 4, 5 divided by 9. It says verify that the mean number of blocks is 5. It is 45 divided by 9. So the claim is that this spot right here is the balance point. The claim is that spot right there is the balance point. Let's see if that's true. Okay. Let's see if that's true. Well, this guy, most of the blocks are not at the balance point, correct? So let's move this guy 1 to the right, and let's move this one 1 to the left. Let's move this one 1 to the right, and now that this one's here, let's move it 1 to the left. Let's move this one 1 to the right, and move this one 1 to the left. How far do I have to move this one to the right?
1.
Well, if I move it 1 to the right, it ends up here. Is that where I want to end it up?
2. So you move it to
2 to the right. So the guy that's currently here, also 2 to the right. How far do I want to move this one?
3.
1, 2, 3, 4.
4.
And 1, 2, 3, 4. So by the time I'm done, everything is moved perfectly to the balance point, and 5 is the balance. Does that make sense?
I have a question.
Yeah.
For number 7, the reason why you moved it twice is because it landed on 6 and then it landed on 5.
The goal is to move everything to 5 because I claim 5 is the balance point.
Okay.
Right? Does that make sense?
Yes.
Okay.
I still don't understand how you know which ones to move. That's not
Well, you
clear to me.
first mathematically determine what the balance point should be.
Right.
Okay, so I did it by the other way, I got 5.
Mhm.
So this one's already at 5, right? Right here.
Yeah.
So then you count. I got to move 1, 2, 3, 4, 5, 6, 7, 8. I got to move 9 times. If I can only move 1 each, I got to move all the ones on the left 9 spots to get them all to the balance point. This one moves 4 to get to the balance point. This one moves 2, and these 3 guys move 1 each. Right? Well, this guy moves 1, 2, 3, 4, 5, 6, 7, 8, 9. They also on the right move a total of 9. As long as the total movement on the left matches the total movement on the right, we know we got the balance point. Okay.
Interesting.
It is kind of interesting. So let's look at this one here. So notice that this balance is actually balanced currently. It's a little tilted, but it's not rotating, which means it's stationary, which means the balance point is at 0. Let's see if that's true. Is that really valid? Well, let's take a look. How many spots would I need to move this one to get to the balance point?
1.
Well, if I move it at 1, I'm not at the balance point.
2.
I got to move it 2 to get to the balance point, right? And how far do I got to move this one to get to the balance point?
6.
7.
6. It's currently at 6 and it's got to go to 0, right?
4, 5. Yeah, 6.
For a total of how much movement?
8.
8. And how far do I got to move right? This got to get to the balance point.
8.
8.
So they're balanced,
2, 3, 4, 5, 6, 7, 8.
right? So they're all balanced. Okay, now we have 2 different measures of center. We have the mean and we have the median. Okay, we have the mean and the median. If the distribution is skewed to the right, if it's skewed to the right, it's common for the mean to be larger than the median. This example, this box plot has the median at 18 and the mean is calculated at 27.67. They did it for us. We don't have to worry about it. Notice how skewed this is. The graph rises quickly here and then takes a long time to drop off on the right side. So we have a skew to the right distribution. The median is at 18. The mean is pulled to the right. And if it's skewed left, it will be exactly the opposite, right? If it's skewed left, the mean will be pulled more to the left and be lower than the median. Does that make sense? Okay, the mean is pulled in the direction of skewness more than the median. Yes? David, you don't like it. You look confused.
Yeah.
Yeah, what?
Yeah.
Yeah, what?
I didn't get what you did with the top bar. Is that a different graph?
So what I did here is as follows. This is a box plot of the data.
Okay.
What it means is the lowest 25% is between this number and this number. The next 25% is here. The next 25% is here. And the next 25% is here. So what that means is that most of the data, 50% of the data is in this section right here, between these two guys, right? Half the data points are bunched up here, which means it's very likely to be here. Lots of data points there, so the graph's going to be high. But on the right side, the graph is very spread out. The data points are very spread out, so there's not a lot of them in any location. So we have lots of points here, so the graph's going to be high here, and it's going to be really tapered off here, because there's not a lot of data points. So this can be very low. The graph is high where there's lots of data points, and it's low where there's not lots of data points. So the graph is going to be a right skewed graph. As such, the mean is going to be pulled to the right more than the median is. The median gets pulled just a little bit, and the mean gets pulled more. And if it was left skewed, it'll be exactly the opposite. Okay, so here, for example, is this a right skewed graph or a left skewed graph?
Left skewed.
This is right skewed. The tail's on the right.
Lori, me too.
The tail's on the right. Right? It looks like this, and then it skews that way. Right? It's not where the hump is, where the tail is.
Okay,
It goes up, and then it tapers off to the right.
that's
So
the
it-
skew.
So the skewness is where the tail is. If this wasn't here,
Strongly skewed.
yeah, if you didn't have that tail, if it looked like this, I don't know if you can see it, but if you can cover up the right side of the graph, it will look very nice. Nice big bell curve shape. But then the right side ruins it. The right side is where the skewness is. The mean is 844 and the median is 769, right? The median is about here. That's where the median is. And the mean is pulled to the right. The mean is further to the right. It's a bigger number because when you're skewed to the right, the mean gets pulled more. Now, there's an outlier here, right? That guy kind of does not belong. If it was not there, what do you think would happen to the mean and the median?
They would get smaller.
Well, the mean certainly would, but the median, I'm not so sure. Maybe a tiny bit. See, outliers, if you're adding numbers and dividing by how many you have, so Lori, 3, 5, 2, 7, 8, 4, and 9 million. What do you think that 9 million does to the mean? If you're adding up numbers like 2, 3, 5, 6, 4, 2, 9, and 9 million, and dividing by how many you have, what did that 9 million do to the mean?
I thought it made it get smaller.
If you have 9 million in there?
Oh, but you're leveling them out, right?
No. Forget about everything we learned today. Just add up your test scores. You got a 2, a 3, a 4, a 5, and a 9 million. What's your average going to be? Forget about the class today. Just go back to 3rd grade. 2, 3, 4, 5, and 9 million. What's your average going to be?
Oh, super low.
Super low.
A decimal point.
There's a 9 million in there.
Oh,
Lori, I'm going to give you 5 lottery tickets. One is a $2 winning. You won $2 in this one. You won $3 in this. You won $4 in this. You won $5 in this. And you won $9 million on this.
oh,
Okay. Would you say you won a lot or a little?
a lot.
Okay. The average is huge.
When you talk about money, yeah, that makes sense.
Hey, I'm Jewish. I know what you're saying, Bill. Okay. Now, what about the median? What happens to the median when you have a 9 million in there? What happened to the median?
Well, it would also go up.
What is 2, 3, 4, 5, 9 million. What's the median?
It's up. Got bigger.
2, 3, 4, 5, 9 million. What's your median?
4.
4. It's the middle number.
The middle number, yes.
The
that's
middle
right,
number.
sorry.
What is it? The middle number does not care that one's 9 million. So when you have outliers to the right, when you have these big numbers, the mean is significantly affected. But the median, not so much, if at all. So if you take out an outlier, the mean will change considerably, but the median will not. Okay, we say in statistics, The median is a resistant measure. It resists change. And the mean is a non-resistant measure. It does not resist change. So a first grade class made this blank of the number of letters in their first names. What kind of graph is this?
The one we did at the beginning.
Is it a dot plot?
This is a dot plot. Very good. This is a dot plot. This is a dot plot. So what's the mean? By looking at it, what do you think the mean is?
Six or
3.
5?
5 or 6?
Okay, 5 or 6, somewhere around there. Let's calculate it. Let's calculate it. What are we adding together here?
4, the 5, the 6. Wait. The
Let's calculate the
blue,
mean.
the blue post-its.
Let's calculate it. How many 4s are there?
5.
For a total of 20. How many 5s are there?
6.
For a total of
30.
30. How many 6s are there?
3.
For a total of?
18.
How many 7s are there?
21.
Well, there's 3.
Oh,
for a total of
there's
21.
3, total of 21.
How many 8s are there?
2, so total of 16.
How many 9s are there?
9.
1.
So 25, 35, 45, 46, 56, 57, 64, 74, 84, 94, 104, 114. Divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20.
Wow.
So I get 5 points.
Okay, let him poop and then I'll change him.
Let him poop in the hall.
Sorry, I forgot that I'm not.
You're letting your kid poop in the hall.
No, he's pooping. My niece is taking care of him. So I said, let him poop and I'll change him.
Okay, good talk. Good talk. So it looks like the average should be about 5.7.
I have a question.
I have an
Sorry.
answer. Yes.
How come you did the 20, 30 and not just add, like, why did you multiply the students and the letters? Was there?
Well,
I don't know how
because
to-
if you think about it, if you just do 4, 5, 6, 7, 8, 9, and 10 and add them together, you're not taking into account that there's more than 1, 4, 5, 6, 7, and 8. You're just taking into account that they're all equal in size, but they're not. There's lots of 4s and lots of 5s, not many 6s, 7s, or 8s, and only 1 9, right? You got to take into account how many there are. Think of it like this. Suppose you took 20 tests and you got a 4 on 5 of them, and you got a 5 on 6 of them, and you got a 6 on 3 and 7 on 3 and 8 on 2 and 1 and 9 on 1. And I say, what's your average? You will add up all your 20 scores, all the 4s, all the 5s, all the 6s, and so on. It's the same thing here,
Okay.
right? Does that make sense?
I have a question. Please
Yeah.
remind me, how'd you get 20? 114 divided by 20?
1, 2, 3, 4, 5, 6, 7, 8, 9,
Okay.
10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the mean is about 6. Right? The mean is about 6. That's what they're trying to say here. The mean is about 6. So make a frequency table that gives the same information. Okay, no problem. I can do that. How many times did 3 occur?
3 occurred 0.
How many times did 4 occur?
4 was 20.
And
No.
5?
5, sorry.
Five was 6 times. How many 6s were there?
3.
3.
3.
7 was 3. 8 was 2. 9 was 1.
Right, for a total of 20.
3.
Cool.
Okay. If we're running out of time, I want to make sure we cover everything that we have to cover here. Okay, so let's talk about the weighted mean. Okay, the weighted mean. Sometimes when you're taking an average of numbers, the numbers are not equal in weight. Here's an example. In his first semester of college, a student took 15 units, earning a GPA of 3.0. He took 12 units the second semester, earning a GPA of 3.5. And the question is, what is his GPA at the end of the freshman year? So at first glance, you say, oh, he got a 3.0 the first semester and a 3.5 the second semester. So on the average, it should be at a 3.25. It's halfway in between. But that's not correct. And why is that not correct?
Because he has less classes. No?
Because he has less classes, which means the 3.0 at 15 units was spread out over more units. So it should be weighted more than the 3.5, which he only was able to did for 12 units. So what is the correct answer? How do we do this? So the answer is as follows. You take each score, so we got a 3.0, and you multiply it by the percentage of units that the student had at that score. Okay, out of the 27 units that the student took so far, 15 of them were at a 3. And the other score was a 3.5. What am I going to multiply that by?
12 over 27.
12 over 27. And then I'm going to add them. So let's do that on a calculator because it's easier. So my answer is 3.2 bar. Does it make sense that it's a little less than 3.25? Does it make sense that it's a little less than 3.25?
Yes.
Yes.
Yes, because remember, it's weighted more to the 3.0, right? So it's a little bit more in that direction. And that's it. The other stuff we don't have to worry about because it just would take too long and it's too complicated. So I'm going to stop sharing now.